Hello, I'm Craig, and I'm a developer. In this course, we're going to be exploring a term that you've probably heard quite a bit. That term is API, or Application Programming Interface. In addition to being able to recite what it stands for, when you complete this course, you'll be able to discuss what an API does, you'll understand why they exist, and you'll be able to list the many benefits that they provide. You'll even get some hands-on experience using a few popular web APIs, which will give you a taste of what all this excitement is about. We'll be starting from the very beginning, so there really isn't too much I'm going to be expecting you to know before starting this course. I would like to request that you have a touch of experience with coding and a wee bit of knowledge about the web. If you've written any program at all, even the typical first program, you know, the one where you write the words, "Hello world," if you've done that in any programming language, you'll be pretty much ready for this course. It'll be helpful for you to have a basic understanding of how the web works with web servers and browsers, but don't sweat it. We'll touch on this too. Now, if you haven't yet met these requirements, please check the notes attached to this video for where to get started with some beginning web and programming concepts. Oh, that reminds me. You should probably take some time to get used to your learning environment. The notes that I just discussed are attached to this video. I'll also drop more information in that section to keep you updated on what might have changed from the time I recorded this. Now, I'll do my best to remind you to look in there when there's something that I think you just have to see. But you really should get in the habit of checking that area out. There will be tons of juicy information there. Now, these videos have captions, so if you feel like you might benefit from having those on, please use them. This space is all yours. If you want me to speak slower, use the speed controls to slow me down. And if I'm taking too long of a time, just speed up. I make a pretty good chipmunk. And last, but certainly not least, take advantage of the fact that you are in a video-based course. If you need me to repeat myself, use the video controls to rewind me. If you feel like you need a break to let something sink in, by all means, please pause me.
I'll be right here waiting for you.
I know that I've gotten into some bad video viewing habits with all the streaming media. Now, while binging might be a great way to consume an entire season of your favorite show, it's not the best way to learn something new. Education isn't meant to be binged. And because of this, I'll probably remind you quite a bit to take breaks and encourage you to let what you just learned marinate. All right, let's get to it. API. Those three little letters generate quite the buzz, don't they? Now, first, I'd like to take some time up front here to clearly break down what is meant by Application Programming Interface. By understanding its purpose and a touch of its history, I think you'll start to see its importance and begin to understand why this term keeps popping up in your life. After we get a good grasp on the what and the why of APIs, we'll go and learn how to explore two existing ones. We'll get familiar with a handy tool, Postman, which provides a nice way to interact with web-based APIs. We'll use that tool to hit an external web API to send actual text messages. And we'll get some interesting data back from a streaming music service API. After some practice using the APIs, we'll insert them into a web application. The application we're going to be building is a web app called Complimenter. Our app will allow you to send compliments to your friends, your families, and your colleagues over text message. And then it encourages them to visit your site and do the same. Now, I've included the final applications in both JavaScript and Python, and together we'll walk through how to use external web APIs to solve the missing pieces. We're going to be strictly using APIs in this course. We won't be writing our own. Now, while you most likely will end up learning some best practices in API design, we won't be covering that specifically. There are many great courses available that show the creation thought process, and I've linked to some of my faves in the notes attached to this video. In my opinion, the best way to start learning about any acronym is to focus on each individual letter. For API, I think we should start on the last character, the I, interface. Let's talk a bit about interfaces that you've seen already. Interfaces are all around us. For instance, this radio here, it has a familiar interface. The interface allows me to do things like change the volume, change the station. I can turn it off and on. I literally have no idea how anything inside this thing works. But still, the interface allows me to control the way it works through the options that are exposed. The magic that is happening is completely abstracted away from me, and I'm still in control of what has been determined that I, a user, can handle. Interfaces usually evolve over time. Like an alarm clock radio, for example. It has my familiar volume and station controls, and it also adds some new features, like changing the time and setting the alarm. I still have no idea how this works implementation-wise, but the interface is something that I can understand, usually. And as technology evolves and new options come into existence, they make their way into the new versions of the interface, still abstracting away things for us, but enabling us to be in control of the new features. Sometimes these physical interfaces get so recognizable that they even make their way into GUIs. Did you hear that? There it is again, GUI, or GUI, Graphical User Interface. This is my streaming music app on my phone, and there's my familiar play button in the user interface, or UI. And I know what that play button does when I press it, but I have no idea how it does it. And I'm okay with that level of abstraction. I depend on it even. What would I do on public transit without music? Like talk to people? Hi, how's it going? Oh. Now the developer who wrote this streaming music application of course understands how the play button works. She coded the button so that when it gets clicked, the music starts playing. Here's the thing though, our developer is also working with quite a few interfaces that are abstracting away some of the details for her. For instance, she wrote code that happens when the button is clicked. She probably did that using an event handler on the button. What she didn't have to do, however, was write the code that makes the button interact and change with the press. She didn't have to write the code that makes that familiar clicking noise. It was already there for her. Buttons are in fact an interface. They provide the developer the means of controlling its interactions, while abstracting away how that actually works implementation-wise. This button is part of the API, or Application Programming Interface, that's available from the application framework that was used to create the app. Because most apps need buttons, this interface has been created to help our developer, or application programmer, to use. Now, by implementing the button interface, our developer was able to make her code run when the button was clicked. It's worth noting that the code probably also uses a media player API that's provided by the operating system of the device, like Android or iOS. This media player API abstracts away needing to understand the details of how to send audio data to the hardware. The developer knows that they just want to call the play method of the media player API. And I suppose, too, the song isn't stored on the device. It's being streamed over the network, so a web-based API call has been made over the internet to get the data. It's actually APIs all the way down to the ones and zeros, providing abstractions at many levels. Let's take a look at what all these interfaces have in common. They all define ways for us to interact or communicate with an object, whether that object be physical or software. And as a user of the interface, we don't need to understand the implementation. We don't need to know how it works. We just need to know what we've been allowed to change or see. Interfaces abstract away the implementation. Now, while the UI, or user interface, is made for the user of the application, the API is made for the application programmer to use and extend in their applications. With the I covered in our API, let's take a deeper look at the rest of the API acronym. An API is a contract of sorts. It defines how it's expected to be used, and it defines what you can expect to receive by using it. Think of it as a set of tools designed for software developers, like yourself. An API is created to help make your life easier by giving you access to data, and by providing you with an abstraction of the implementation. You know, not needing to know how it's doing whatever it's doing. They save you from needing to create everything yourself. When designed well, they make doing nearly impossible things happen in just a few lines of code. You're probably starting to see why it's important to get familiar with them, right? I want to do a quick word of warning here about some naming issues that you'll probably run into. These days, the term API is almost always used as a way to explain web-based APIs. In fact, it's probably safe to assume that when you hear API in the wild, it's most likely that people are talking about a web-based API. Now, we'll explore those here in a few. However, if we focus on all types of APIs instead of just the web-based subset, we'll get a better look into why web-based APIs are so popular. So hang tight, we're getting there. APIs are everywhere in your software journey, just about everywhere you look. Your programming language, whichever one it might be, provides many APIs. Let's take a look at one that's common in all of them. They all provide some way of working with strings, like a series of characters. You want to make your text all uppercase? Just call the API method and voila. You could probably create that uppercase string all by yourself by doing some sort of low-level bit math on each character, but you don't need to, because your programming language has abstracted that away for you and provided a handy string API. It exists because this is a common enough problem that developers run into. Because these programming language specifications are just interfaces, different operating systems can supply their own implementations so that the code works properly in their environment. I think an easy way of picturing this is to think about how different operating systems like Windows or Mac OS maintain their files. They're totally different. Yet your programming language provides a single API for working with the file system. You can write one script and it works in either Mac or Windows. It's the implementation that takes care of all the details for you. Pretty cool, right? Definitely something to be thankful for. It makes our lives so much easier not having to worry about what operating system is being used. The importance of an API to a language cannot be understated. There's been some fascinating legal cases where it's been questioned if the language API itself, again, not the implementation, can be copyrighted. Check out the notes for more on that. Along similar lines, there are different web browsers. Like Google Chrome, Microsoft Edge, Safari, Firefox, and Brave. Now, you might not have pondered this before, but isn't it amazing that you can write code for the web and it will work in any of them? Now, this works because there's a set of web APIs that web browsers all must implement in order to make that magic happen for you. We're standing on the shoulders of giants, folks. We really should thank those giants more often. There are authors and maintainers of libraries that package up code and solve common problems so that you don't need to do it yourself. Like, for instance, do you know how to programmatically make a photo black and white? Me neither. But I can download and import an image package into my application, and suddenly I can. I just call a method, and boom. I wish real-life skills worked this way. I'd import dancing so I could be more fun at weddings. Cha-cha-cha. Frameworks provide an API that allow you to extend what has been provided to make it your own. Like, for example, most web frameworks provide you with the ability to add a new route to your web application. It allows you to write out dynamic data to a template that you specify. And you do all of this with just a handful of lines of code. You don't need to understand how it's doing things, but you do need to know how to write an implementation to what the framework is expecting. In this case, you're using the API, the contract, to write a valid implementation that meets the requirements. Now, all these APIs that we just talked about, they're local to our code base. They exist within our code. We use them to avoid recreating the wheel. That is to say, they assist us in accomplishing tasks that we need to perform by abstracting away a ton of work for us, the stuff that we developers shouldn't be worrying about. We should be focusing on the business problem at hand. And that means a big part of your job is figuring out how to leverage these APIs to your advantage. Now, I think it's an excellent time to take a quick break. I just gave you a lot to think about, and I'd like you to take a minute to breathe. Why don't you jot down some APIs that you've used today? Even if you weren't coding, I know that you've seen some in action. If you're having a hard time thinking of some, I'll give you a hint. You're watching a video right now inside of a web browser. When we return, we'll explore the concept of remote APIs, ones that aren't executing locally in our code base, and why that's such a powerful concept. It took me a while to find this remote control. It was in the couch. It's always in the couch. Anywho, this remote has an interface on it, right? There's the power button, and there's a channel changer, and when I press the volume button, it sends my request to my device, and the volume changes, as if I turned the volume up using the interface on the device itself. And we know why that's important. I want to remotely control my device. I don't want to get up from the couch. There are, of course, more or less lazy reasons as to why you might want to remotely control objects. This cute little robot, for instance, has a remote API. You can send commands to it, and it responds. It even sends back sensor information. These traffic signs can change based on an API call.
This drone here is actually remote controlled by an app on my phone. See?
It's not just physical objects that benefit from remote APIs. Oftentimes, we don't have space on our local machines for all the data that's available. Like, for example, have you ever used one of those apps that helps you figure out what song is playing? You send up a snippet of a song you heard playing at a grocery store using your microphone, and it sends back exactly what the song is. It's usually Phil Collins. Turns out both grocery stores and yours truly loves Phil Collins. You don't have room for all the songs in the world on your phone, and with this remote API, you don't need to have all of them. It does all the searching and processing, and it's surprisingly quick. How can it possibly do that? I don't know, but I love the interface. It's so fast. Oh, there's another benefit of remote APIs, computational power. Because an API removes the limitations of your local machine, you can gain access to seemingly infinite amounts of power. A good example of that is the AR app of Google Translate. You can use the camera on your phone, and in near real time, it's able to translate directly to your screen, like instantaneously. It's using a ton of processing power to make this magic happen, and that processing is happening elsewhere, in la nube. It took quite a bit of experimentation and some evolution of ideas, but over time, we finally turned this remote API dream into a reality. Now, I'm going to drop some history in the teacher's notes, but I just want you to know that the struggle to achieve this concept of remote APIs was very real. Now, most of the problem was that there wasn't a standard that everyone loved. Things were pretty clunky for a while as the ideas were sussed out. But then it happened. A new architectural style appeared that was clear and allowed us developers to interact with specific resources over the web. And it quite literally changed everything. This style rapidly emerged as a winner, and just about everyone began offering and consuming APIs over the internet. Now, what I'm talking about here is REST, or Representational State Transfer. It was the approach that we needed, and honestly, it's the abstraction that we developers deserved. Like we talked about already, the popularity of REST spread so rapidly it nearly completely overtook the term API. It's like how we use the word Xerox to mean photocopy, even though Xerox is just a brand of photocopier. Xerox does other stuff too, I think. That's how pervasive REST is. REST is for sure not the end-all, be-all of remote APIs. There are definitely some limitations, which we'll discuss here in a bit. Technology is ever evolving, and of course, there are movements that are still advancing the concept of the best remote APIs. Some terms you might have even heard, like GraphQL. More on this in the teacher's notes. Now, for the rest of this course, we're going to be doing a deep dive into APIs that are written using the REST style. When APIs embrace the style and constraints of REST, they're said to be RESTful. Cute, right? If you're feeling like you need a little rest, go ahead and pause me before we do a deeper dive into what it means to be RESTful. Sorry, that was a bad and obvious joke, and as a developer, you kind of have to make it. You don't really have an option. And because REST sits on top of web technologies, we should probably do a whirlwind refresher of how the web works. It might have been a while since you thought about how the web works. There are a smattering of terms that I'd like to reload into your working memory before we talk more about how REST uses them. So let's use the web. I've got my computer here, and on it, I have an internet browser. This browser is a web client, and I'm going to use it to connect to a server. I'm going to do this by putting a location in the address bar, a universal resource locator, or URL to be exact. You might also hear this referred to by its superset term, URI, or Universal Resource Identifier. Now, our URL here has a scheme portion, and this one happens to be HTTP. HTTP stands for Hypertext Transfer Protocol. Let's break that down a bit. Let's grab that last part, protocol. A protocol is also often likened to a contract. It's a little lower level than an API, but it's similar in concept. You can think of it as defining the expectations of how to communicate. An example that I find really sticks with me is if you've ever been to a rally and someone does one of those chants where they go, "When I say foo, you say bar, foo, bar, foo, bar." Here, let's do one. When I say HTT, you say P, HTT, HTT. Oh, I just realized I might have made you yell P out loud. I hope you're in a coffee shop, that'd be awkward. Anyways, you and I, we just set up a real quick protocol. I told you how to respond to my specific request. You would have been breaking our agreed upon protocol if you yelled anything else but P. So the browser creates an HTTP request for you. Along with the URI, it also specifies a particular HTTP verb. In this case, it's using the get verb, which is used to clarify that this request will only receive data. That is, it won't be making any changes. The server receives the request that was transferred from the client. There's that second T. The server then does the work that it needs to do. And finally, it generates the resulting web page and sends back a response to the client, my browser in this case. Now, the most important part of that response is the body. For a web page, that contains the HTML, or Hypertext Markup Language, which gives us the remaining parts, the HT of our acronym. Hypertext is text that can link to other text. In HTML, we perform that linking with anchor tags. So with that response, the browser renders the page. When one of those links are clicked, they kick off a brand new HTTP GET request, and the process repeats itself over and over. In between those clicks, though, the protocol is done. We made the request, we got the response. HTTP, as it was originally designed, is a stateless protocol. Once that request receives a response, it's all done. If you want to keep some sort of state, your client will have to manage that itself and send it up with each new request. Check the notes for more on this. There are more HTTP verbs, also known as request methods, besides GET. Most common scenario you see is when you encounter a form that is used to take information from you. Typically, you'll see the verb post used to explain that you are submitting or posting data to the server. Okay, so our protocol that's used to transfer this hypertext is admittedly a little more complex than our rally chant was. There's quite a bit of important information that's included in both the request and the response. You've probably seen query string parameters in URLs, the stuff after the question mark. This is one way to pass information about the request. Another common way this information is passed around is through specific key and value pairs called headers. Both requests and responses have headers, and they're used to help further communicate what is wanted, as well as what has been sent back. Now, some of the popular request headers allow you to specify information about the content that you'd expect back, like the language or the type of content. You can also state you only want a page if it has changed since a certain time. This technique allows for caching, which is a powerful concept. Why get the whole page if you already have it in your local cache? You can embed authentication information in each request using a header. This way, you are essentially keeping your client logged in across requests. The response also contains headers. A super important one is the status code. This lets you know what happened on the server side, and it can convey things like missing documents. I'm sure you've seen the old 404 error, the page has been moved, or hopefully everything is A200 OK. It can also explain the content type, how large the data returned is, and many more things. Okay, got it? Feeling good about that little whirlwind tour? Remember, feel free to make me repeat myself if that was way too much. I totally get it. That was a lot of information. It's important to have a basic understanding of these things because REST sits on top of them. It uses the concepts that were introduced with the web to expose resources that can be accessed and manipulated. Let's take a look at how the RESTful approach takes advantage of the web and its tooling for your benefit and profit. REST stands for Representational State Transfer. APIs that meet the REST architectural style constraints are considered to be RESTful. A typical way to teach about RESTful APIs is to cover the constraints that define it all up front. I don't know about you, but personally, I find approaching learning that way pretty overwhelming, especially from the beginning. I mean, we haven't even looked at an API yet. And on top of that, most of the REST APIs that you use will meet all of these constraints. So here's the thing. I promise that we'll go over all the constraints, but let's do it on our own time. Like, don't learn them all right this instant. We could even make it a fun journey, like a RESTful constraint scavenger hunt, complete with prizes. Here are the guiding architectural constraints required for an API to be considered RESTful. We'll check them off when we discuss them, and then we'll loop back once more at the end to review. Gotta collect them all. Sound fun? Good. Let's get started talking about how REST APIs sit on top of web technology, like a little hat. Much like the web, the client makes a request to a server. The client, in this case, is typically going to be your program, and you'll probably be using some sort of library to create the request to the server. The protocol used is, you guessed it, HTTP, and it's stateless. The server won't remember anything about the particular client. If you want to maintain state, like your login details, you must send it with each and every request, and you'll do this using headers. And just like that, we've talked about two of our REST constraints, client-server architecture and stateless. You got two knocked off already. You're on a roll. Now, we should probably talk about what that request was requesting, right? Well, it most certainly was requesting information about a resource. A resource is a little abstract, and that's intentional. It's the R in the URL, or URI. We use the term resource to reference an object, which also happens to be pretty abstract, right? This is because we can use resources to describe just about anything that we build. For instance, let's imagine an ebook store website. On the home page, maybe there's a list or a collection of new books. Each of these books is a resource. Now we click into that to take a closer look at the book resource, and we see a link to the author, which is also a resource. We click into the author resource and we see a collection of all the other books that they've written. Maybe we even see a group of fans, again, another collection, and each of those fans are a resource. Clicking into a fan resource, we can see the collection of their favorite authors and books. Everything is a resource. Let's change gears. How about an image sharing application on our phone? So we have user resources. Those users post photos, which are resources. And the photos can be loved, so there's a lover resource. Maybe there's an album that could be created, and there's an album resource that contains photo resources. And albums have a collection of contributor resources. Turns out almost everything we ever want to build can be expressed in terms of resources and collections. Most of what we want our applications to be able to do to their resources can be expressed through the unfortunate sounding acronym CRUD. And that stands for creating, reading, updating, and deleting. Now, as a user of the ebook site, all we did was a bunch of reading. No pun intended. Actually, I did intend that one. We were reading, right? Just getting the information to display it. Like, we retrieved the author page. We made a read request for that page. The web browser used a GET request to that specific author page. Now, the RESTful API follows the same logic. Your program sends a GET request to a URI. Then, the server responds with data, and of course, all the HTTP headers that you've come to know and love. And the body is typically represented these days as JSON, or JavaScript Object Notation. Now, JSON provides a great way to structure and nest your data. Every programming language that I can think of provides some means of turning a JSON string into a native object. Content type is typically something that you can specify in your request, if JSON isn't your thing. Now, if you recall, there are other HTTP verbs available. These verbs are used in REST APIs to clearly state the intention of your request. Want to add an author? Post to the /authors and send the data that you want to update in the body of your request. These fields will be defined for you somewhere. Want to remove an author? Send a delete to that specific author. Updates typically support the patch verb. And you'll see we're able to represent CRUD, the create, read, update, and delete using HTTP methods. Pretty cool, right? What this means is that you can interact with any application out there that's exposed their REST API. You could grab data, remotely automate tasks, and even smush services together. This is called a mashup. And here's the thing. There are tons of APIs available. Just about anything you could imagine. And if they're truly RESTful, they'll all feel pretty much the same. You can build anything. There are services that allow you to do incredible things with a few simple API calls. So now the question becomes, what are you going to build? Why don't you take a quick break, and when you come back, let's explore a RESTful API together. We'll take a peek at how to use the music streaming service, Spotify, and their excellent RESTful API. You have some newfound understanding of how web-based APIs work. I walked you quickly through some imaginary REST APIs, and now I'm thinking it's time that we get a little more specific. Why don't we go exploring together? Now, some of these REST APIs allow you to give it a try from the comfort of your very own web browser. One of my personal favorites that allows for exploration is the streaming music service, Spotify. So here I am at Spotify.com, and a quick word of warning, this for sure is going to look different by the time you get here. There are teams of people working on the site to make it better, and you're going to have the benefit of a better website than I have right this instant. So just a reminder, you should check the notes attached to this video for any breaking changes. And if you don't have a Spotify account yet, don't sweat it. As you can see, it's free. And that same user that you can create, you can end up using for development purposes. So let's assume that I didn't know that Spotify had an API. Now, what I usually do is I look around. So typically, most sites store the nerdy stuff down here in the footer. There we go. Developers, that's what we're looking for. It's a community of developers. That's us. Let's do it. Wow, I love a site that treats me well, even as a developer. This is really nice, right? So you can do a ton of stuff since I was last here. Let's take a look here from the front. So audio analysis. Wow, you can learn about danceability. Maybe I will be able to install that skill after all. Oh, cool. Audio playback. So you can kind of, nice, you can embed a player, right? Right in there. You can put a player into your application. An SDK here, that stands for Software Development Kit. And we'll look at one of those here in a bit. But basically what it does is it gives you an API that wraps around other APIs, and it will feel native to your programming language. Cool. And then let's take a look here at recommendations. Oh, awesome. It will give you specific recommendations. Awesome. This is great. Target danceability. I'm going to be able to dance. And see this JavaScript here, it's doing a get to one of their endpoints. Awesome, this looks good. So let's take a look up at the top here. Let's go ahead and discover. That's what we're trying to do. We're trying to discover what we're going to do with this API. So let's click into here, and this will give us some ideas of what we can do. Let's see. Real apps that integrate audio features. And this is awesome. I love when sites do this. I find that it's a great way to get inspiration. If you don't yet have an idea of how you might use the API, you can see how other people have used it. Cool. So this is the audio analysis that we had seen. Quick dashboard of audio features of songs. And there's that danceability again. Here's playback. So you can get a player. This is super neat. And these are apps that use them. iPhone app, a listening room, Runkeeper. So you can see here, this is for iOS and this is for Android-based phones. So iOS being like Mac-based products, and this is Android-based products, and this is widgets. I'm not exactly sure what that is. I'm assuming that's the HTML widgets that we had seen. And that's cool, right? Because it's a web-based API, all we need to do is to connect to it over HTTP. So any of these devices can connect to it. Pretty slick. All right, let's keep going. So we've got recommendations. That's great. I always need music recommendations. Search. Ooh, that's nice. That actually feels like a good place to get started, right? Like if we went and we searched for different things. So there's 6 Degrees of Kanye West. I guess a lot of people are connected to him. Find other artists that are like the artists you like. This is great. Why don't you say we look at some of the documentation for search? So I'm going to click this read the docs. Let's read the docs. Ooh, nice. Now you might not see this, but there's a brand new web API reference in beta, which means it's not quite ready for everybody, but it's ready for people to try. I'm going to go look at that. You might actually be there and be out of the beta period by the time you see this. Okay, so let's take a look and let's see about this search API. Let's see. Search API. So let's go ahead. Let's click into there. As you use more and more APIs, you'll get super familiar with reference documentation like this. This is explaining the contract of what we need to do to use this API. So you'll see here that there's different parts. So this is what the request is that we're going to be sending. And it's saying here that this is a header. And this says whether or not things are required. And this indeed is required. So this is authorization here. There's a header that's required in the request for authorization. Now, authorization means it knows what you're allowed to do or authorized to do. Spotify and many other APIs use the concept of access tokens. So that's a header. That's the header that's required. And so here we see this query parameter, right? So query parameters, and you'll see that this one's required, this Q. So this is the search query, the keywords, right? So, and here's an example of what that is. And this is showing you that it needs to be URL encoded. There's some more notes on this here in a bit. So note, we have Q is required and also type is required. And type is like album, artist, playlist, like the type of resource that is available on Spotify's API. And if we keep scrolling down, there's more optional query parameters that are available. Will really help you specify your search. Very rich API they have. And then it shows you this response. So this is what's going to come back. So you'll see that you'll get a header and the status code, very important. We'll say 200 OK if it's good on success, right? On success, it'll say 200 OK. And the response body contains an array, so like a list of artist objects or album objects, whatever it was the type you were looking for, and it's going to be in JSON format, just like we talked about. JavaScript object notation. And so you'll see when there's an error, there'll be an error code, and the body will have the error message. And then there's some more notes here, and these are really thorough. This is great. So encode spaces. That's what we saw. We saw that %20. It's making sure that you can't use a space, otherwise it breaks the URL. So this is how you do that. You'll see there's lots of different information here. Yeah, you can use asterisks and show you in all sorts of ways to do fun queries. Let's go ahead and try this out in the web console. It's pretty slick. So what this does is it lets us search for an item, and it's showing us how it's doing. It's doing a get, and it does have some authentication required. So we will need to build something here. But you'll see over here, it's showing what it's doing. It's doing a get to this URL. And this is code here that will actually run. And you'll see as we change the fields here. So I'm going to change this to a very popular artist around my house, Lizzo. And you'll see that it updated over here. It updated my query, and the type is set to artist already, so that's fine. And we have this OAuth token that we need to get. So we need to get this token. So again, this is the what are they authorized to do. So we're going to go and choose get token. And it's telling us that this specific endpoint doesn't require any specific scope. So these are scopes that you can do. So when you build this token, it's saying for using this key, these are the things that the people are able to do, and we don't need to do anything specific for this. So let's just go ahead and let's not check any of these. We don't need to modify a private playlist. We don't need to do that. So we're going to do request token. And here it's going to ask us to log into Spotify. And if you have Spotify, go ahead and log in. And if you don't, remember, it's free. You can totally just come in here and do sign up. And we can put in our emails here. So I'm going to put in mine. And here's a little trick. If you don't know this yet, I'm going to put in API course. Let's do API course like this at gmail.com. My email address is craigsdennis@gmail.com. But if you put a little plus here, you can kind of categorize things your own. So just a little trick. And that way, if you're worried about emails coming in, you'll know that they're coming in from that address. I'm going to do the password to my luggage, which is 1, 2, 3, 4, 5. Just kidding. What should we call you? I love it when you call me Big Papa. All right, so my date of birth is November 19th, and I was born in the wonderful year of 2000. Just kidding. This is awesome. I love this Spotify. Thank you for being inclusive. Inclusivity matters. I'm going to choose mail. I don't want to share my registration data, and I am not a robot. I promise. I think I'm not a robot. Identify the crosswalks. What is that? All right, so there's one. It's definitely a crosswalk. That's a crosswalk. I mean, I could walk across the street here. I could. All right. I passed. I'm not a robot. I'm going to click sign up. Here we go. Whew. I'm going to save that password. I'm going to turn on sync. Logged in as Big Papa. Here we go. So I'm going to click agree. And I'm going to pop back to the page, and you'll see now this is filled out. Now, one thing I do want to point out here is that my token here, my key is on the screen. And if a hacker were to pause my screen and copy that down, they could essentially do things to my account on my behalf. But I, of course, know that, and I'm going to delete this token later. Remember, this is like leaving your car keys on your driver's seat. You probably don't do that. So treat these keys the same and keep them safe and with you. So I could just copy this whole command and paste that into my terminal and it would work. We'll do that in a bit. But what I want to show you first is that you can do this try it button here. And what happens is what comes back is this beautiful JSON. So you'll see that what's being returned here is this artists, and it's an object that has the search that we built. And then here is this items, and you'll see that it's an array because there could be multiple artists named Lizzo. And I guess looks like maybe there is. Yeah, it looks like there's actually another artist named Lizzo, popularity 88. And what's this Lizzo's popularity? Her genre is escape room. Man, I feel old. One thing we can do is we can look and see if this there's these external images, so you can kind of take a look and see if it's them. I'm going to click go to here, and we'll see what happens. And there she is. Lizzo is on all the time at our house. Once my daughters figured out that Alexa could play music, they're like, play Lizzo. Alexa, play Lizzo. Alexa, by the way, is a voice user interface, right? There's the I again. So I'm going to get back to our tab. And we will go now, and we see here that she has an ID because we're in this artist, right? So we see here that she has this ID. I'm going to go ahead, I'm going to copy this. And you'll also see that there's another API call here that we can do. There's this href that will get her specifically, right? So there's the /artist and there's /her ID. So if we call that, it would get information about her. Again, I'm going to make sure that I copied her ID here. I'm going to scroll down a little bit more. I think there's the other Lizzo. Let's look. I think there's a thing where we can look at the page. Yeah, here we go. So here's external URLs. And you'll see this is in the API. This is the actual Spotify page itself. So if I'm going to do this and I'm going to right click and I'm going to say go to. This is Lizzo's actual page. And this is how it's displayed, right, as a web page on Spotify. If we scroll down here, we'll see that there's this popular. There's her popular songs. Good as hell. Great stuff. If you don't know her, use this link, learn her. I happen to know that we can get a list similar to these popular songs using the API. So let's go back to our reference. Okay, so we're back here in our reference. Let's look at the artist API. So we're going to click on artists. And again, I'm going to go into the beta web API reference, might be what's live for you. And I'm going to click into the artists API over here. I'm going to scroll down a little bit. So there's get an artist albums. And what else do we have? Get an artist tops tracks. This is exactly what I wanted to do. Okay, so again, here's the docs about that. I'm going to try this out in the web console. Okay, so get an artist tops tracks. It's going to do a get, and this is the endpoint. So we're just going to, it needs that ID, right? So we're going to put that ID in there. It's coming defaulted with somebody's. So I'm going to go ahead and paste Lizzo's in there. Okay, and the country is US, and you'll see that again, it's changing. So see how her ID's here. Country's US, and we're going to pass our private keys along. I'm going to click try it. All right, so now we've got a list of tracks, and each one of these tracks has what album it showed up on. Okay, so again, this will be in the same list, their top tracks as we saw on that page, which is super neat, right? There's the 'Cause I Love You song. And let's keep going a little bit. You'll see how the URIs here, they use a different style URI with the colons to separate, but it's Spotify artist and then the ID. And then we'll see here that there's this preview URL, which you could actually just go ahead and open, and it will start playing this song. Pretty cool, right? You can get access to all of Spotify's music library, and you can build tools that extend their platform. I highly recommend that you go and take a look at what people have built using these APIs. Super impressive. Did you notice how fast those results came back? How could it do that search so quick? Oh, wait a second, does it even need to? The results don't change all the time. It's not like Lizzo is dropping a new song every minute, though I wish she would. Those results are definitely cacheable. Ding, ding, ding! Cacheability is also available on the client, and we'll get to that here in a bit. But this is a great example of a layered system. I'm almost positive that Spotify has set up things so that it returns that same JSON from its own server-side caching mechanism. It's not rendered on every request. Now, as a user of the API, I don't know how it's doing that, and frankly, I don't care. I want it to be available and fast when I hit that specific URL. And as Lizzo might ask, baby, how you feeling? I'm feeling good as hell. That was fast. Spotify is just one REST API. There are tons and tons of services out there. There are even services that exist only as APIs. Let's go ahead and take a quick break. I'd love for you to take some time and think about what you might be able to build with the Spotify API. For instance, while I was using the API, I had this idea pop up. I'm often at festivals and I'm having a hard time figuring out which band I should go see. There's so many. I'd love to have an app suggest me which of the bands that are playing that I would most likely enjoy based on my listening habits. I'm pretty sure you could do that just by using the Spotify API and a list of the bands performing. If you end up building this app, please share it with me. What other interests do you have that provide an API that you can use? Check the notes for more ideas. After you come back from your break, let's dive a little deeper and make use of an API using our own tools. See you soon. No, really, take a quick break. Seriously, it'll do you good. No binging. While I realize that exploring an API on a website is informative, it might not feel like you're actually using that API. I think the next logical step in exploring is actually making that request yourself from your computer, not from a website. Let's use a different API. This time, let's use Twilio. Twilio is a company that loves APIs. In fact, that's most of what the company is. It's a company for developers that helps abstract away telephone communications. Well, actually, all kinds of communication channels. It lets you bring communications into your applications. It allows you to make and receive calls and text messages and a whole slew of other things. I need to be a little upfront with you here. I love Twilio. I mean, I love it so much, I even applied for a job with them, and I got it. But even if I didn't, I would still show you how cool their APIs are. I mean, with a single command, you can send a text message. I remember when I first did that, I was like, wow. That level of abstraction is amazing. How does that work with all the different cell carriers, the varying standards and networks? I have no idea, and I don't need to. That's the beauty of this API. Let's get started.
So I'm here at Twilio.com, and again, a word of warning, this will most likely look different as Twilio is constantly making improvements. So please check the notes for any changes to this flow. So first things first, let's sign up. We'll be able to use a free trial account for the rest of this course. Let's sign up with my information. I am Craig Dennis. And again, I'm going to use that trick. So I'm going to say Craig S. Dennis plus, let's say API course, in case I've already done that one, at gmail.com. And I will set my password to and I am going to accept the terms and services because I've read that. And I'm going to start my free trial. Save my password. There we go. And it's sent an email to my Gmail. I will go check that real quick. There we go. I've got a email and I am going to click that link. Let's do this. I will paste it here. Verify my account. And I am logged in. All right, so I'm going to put in my phone number, which is 503-461-5537. And this phone number you provide will be used for authentication for the Twilio console. Somebody might contact me with free onboarding. That sounds great. I'll check that. I'll click verify. So 708-655. So in trial mode, we can only communicate with numbers that we've verified. So do you write code? I do. I write code. I write Python code. My goal today, I'm going to use it in a student or hackathon project for sure. I'm going to send or receive SMS. SMS is a short message service, which is text messages. We're going to send text message. So the way Twilio works is you buy an actual phone number. Let's do it. So we'll get this trial number here. This number got automatically selected. It's fine by me, 201-584-8089. And I'm going to choose it. I'm going to say choose this number. And just like that, the number's mine and I can program it. And we'll do more with that later. So I'm going to click done. So there's some notes here, right? You can only send messages and make calls to verified numbers. That's how our Twilio trial account works, right? Notice also we have $15, which is more than enough money to do anything we're going to do in here. And it also says that messages and calls include a note about this coming from Twilio trial account. Okay, that's fine. What do you say we send a text message? Let's do it. So the way that things work is over here, there's a little menu and we have different things. As you can see, there's a bunch of stuff available. We're going to choose this very first one here, this programmable SMS short message service. I am also going to pin that to the dock so that I can get to it easier. So it'll always be there. Okay. So you'll see here, it's pinned. On this page, I'm going to choose Get Started. Let's do it. Now this step allows us to explore the API like we saw on the Spotify site. You'll see as I change things here, so let's change this body to say ahoy, you'll see that it changes the code that's over here. Fun note here, ahoy was the first word ever spoken over the phone, so ahoy is kind of like hello world of phones. So I'm going to go ahead and click make request, and I got the text. Of course, it's prefixed with sent from your Twilio number, but whoa, right? I just sent a text by pressing a button. Let's take this a step further. I'm going to copy this code. And actually first, before I do that, I'm going to check this show your auth token. Just like Spotify, Twilio uses auth tokens and they're private keys, but I trust you. And also I'm going to delete this later. I see you hackers. So now if I come over here and I click this copy icon here, it will be in my clipboard. Now I'm running on a Mac, so I'm going to open up my terminal and I'm going to paste. So see how this is the URL that we are going to post to, right? We're going to post because we're going to be creating a new message. Notice here, this is my account SID or string identifier. And because we have JSON here, this .json, that tells the Twilio API to return JSON. And we use form URL encoding here. This is what this data URL encoding is. And this is the to. We're going to send it to my phone number. And it's going to be from our Twilio number. And the body is going to be ahoy. So I can come in here and I can change this code, right? So I can. And instead of ahoy, I'm going to make it say ahoy from terminal. And this -u here is setting up the authentication of the account SID, and this is my auth token. So when I go ahead and press enter, we'll get some information back, and it tells me that it was successful. It will give an error if it didn't. I got my text message. So this command is sending a post, which is great, but I can also use get to receive the messages that have been sent. So kind of like a sent log. So what I'm going to do is I'm going to use the up arrow and get the information back. I'm going to change this to get. And then I'm going to get rid of the rest of these lines, which I'm going to do with get in here and do Control K. On the Mac, look in the notes for how to do this in Windows. So we're going to say all of the messages that were sent to this. And if I go press enter, that didn't work because I left the trail at the end. I'll press up again. So I'm going to get rid of this trailing slash because that means like continue on to the next line. So here we go. Oh, I need to have my account SID. So let's do that again. Let's go press up a couple times. So I forgot that we're going to need to keep our information there. So let's just go ahead. I'm going to get rid of all of these lines. So again, that's Control K, and this is -u. So we're doing a get to this account, and we're saying all of the messages that were ever sent from this account. Let's take a look at that, and we're doing a get, so we're not doing a post. So we're going to show a list. There we go. So again, you could format this or make it prettier, but for now, though, let's keep exploring some more tools.
Awesome job getting that running on your local machine. Feels pretty good, doesn't it? What a cool skill you now have. You can send a text message from your machine with just a single command. Now, believe me, this is just the tip of the iceberg of what you can do. There are so many more Twilio APIs available, but for now, let's take things a step deeper. Now, I don't know about you, but I'm a little clumsy when it comes to long commands on the terminal like we just did with curl. When exploring APIs, I really like to lean on a tool called Postman, and I think you'll enjoy it too. Why don't you take a quick break, and then we'll check out Postman. Postman is a wonderful, feature-rich tool that I use all the time to explore new APIs. It started out as a Chrome extension, but recently became a full-fledged application. It's super handy. I love how it can help you organize your learning, and I think it's an excellent exploratory tool too. Let's dive in.
Postman can be downloaded at getpostman.com. Now, go ahead and pause me while you get it installed. It's right here. Download the app, and I'll wait, and when you're done, unpause me. All set? Okay. So here it is. I've got it installed too. And when it comes up, it will have this create new. And typically when I end up using this tool, I'm working with a specific API. And what I like to do is to create a collection to keep all of the requests that I make grouped together. So I'm going to choose a collection here. So create new collection. Let's recreate those calls that we made to the Twilio API using curl. So let's do that right here. So we'll call this, the collection name is going to be Twilio. And then I'm just going to click create. Down here, there's a little window thing, a little bar over here. So you can see that you've got your collections over here. So we have a new one here called Twilio. And in here, you'll see that we can add requests. So I'm going to go ahead and click add requests. So let's build that message log. Remember, that was the get that we did over in the terminal. So I'll name this request. That request name is message log. And I like to make a description here about what's going on here. So this will be, this is going to be all messages sent from my account. That's what we were looking at, right? That's what that message log was. And if I'm taking notes, usually what I do is I drop a link to the documentation about what the resources that I'm looking at. That way I have a quick way to get back to it, to look at it. So one way to do that is just go find the documentation. So if we just do Twilio, message, resource doc, that's what I had there before. So that's going to find the resource for the messages and resource reference. That's great. And the way that the code here works here is very similar to like we saw on Spotify, the different things that are available. There's the create message resource, and each one of these kind of has its own little heading, and there's some code over here that we can switch. So I want to look for list all messages. That's what we want with the message list, right? So I've got this example, and I'm going to grab the URL. And I'm going to come back over to Postman and just drop it in there. And Postman uses here, this is Markdown. So I'm going to use brackets and say Twilio documentation. And then if I put parens, I can paste the link there. And that will make a link inside of my notes. Let's scroll down a little bit here. Twilio offers a ton of different APIs. So I could break this down even further with this thing called a folder. So let's open this up actually, and let's make a new folder here because, you know, there's so many different APIs. We might be playing with a bunch of different things. So what I like to do is put these in folders. So let's make a folder. We'll make the folder called SMS. Okay. And we're going to add that to the SMS folder. Okay. So what this is saying is we're going to make this new request. We're going to create a new folder called SMS. And when we click save, we'll see that here underneath Twilio, we have this SMS now, and there's our message log, as it were. And so what's happened here is it's created a tab for our new request that we've made. And you'll notice that there's a little twisty here, and there's a tab, and there's the link to my documentation, which is handy, as you'll see as we're going through this. So let's go grab that URL that we had. I'm going to go back to my terminal. And I'm going to press the up arrow, and I have that there. If you don't have this, go ahead and look in the notes, and I've got a copy for you. So I'm going to copy that. I'm going to come here. I'm going to put the request in here. One thing to notice over here is there's this drop down that says get, and we can send different types of. Here's the different verbs, right, that we can send across. HTTP verbs, a bunch of them. And we're going to leave it at get right now because that's what we're going to do. We're going to get the messages. And I think we're all set. So let's go ahead and click send. And uh-oh, we got an error. You'll see that we got back a 401 unauthorized. So if I mouse over it, I see more information, which is nice. And if I scroll down here a little bit, here's the error message that came back from Twilio. It says your account set or auth token was incorrect. And oh yeah, we didn't even pass them. So you can add that authorization to your request by this little tab here. So next to params, it says authorizations. And here we'll say type inherit auth from parent. Oh, that's actually a great idea. We're going to be using the same account SID and auth token anyways, so we should just use it from the parent, right? So I'm going to open up my Twilio collection, which is here. So if this screen ever gets closed, this little guy here pops out. So I'm going to go to my Twilio collection and right click on the buttons here, and I'm going to choose edit. There we go. And we'll come over here to authorization. So what this does is all requests will share this if they have, inherit from parent. So we'll go to this authorization. It's used for every request in the collection, which is what we want. And we're going to change the type to be basic auth, which is what we're using there. So we'll click basic auth. And look at this. We were going to put our super secret information here, but it's saying, heads up, these parameters hold sensitive data. To keep this data secure while working in a collaborative environment, we recommend using variables. I don't know about you, but whenever I see security warnings, I like to follow that. So let's follow that. So there's variables here. So it says learn more about variables. If there's also this variables tab up here, right? So let's click into variables. Okay, so what these do is we create a new name and it will have a value, and people can set on their own machine these own values. So this is a good way of not accidentally sharing out your keys. So the things that we want is we want to have the account SID, which is a string identifier. So Twilio account SID. And the way these work is there's this initial value. This is what people will see when they come in. So we want them to fill out their own. So we'll say your account SID. So if anybody is using this, you're going to share it. That's what they'd see. And we'll get the current value. So that's over in my Twilio console. So if I go to Twilio/console, which is the main page once you log in, you'll see here that I have my account SID. Here it is. And then there's a little copy button. So I'm going to copy my account SID. And we will paste that. And the current value is my account SID. And then we'll do another one. We need the auth token. We'll say Twilio auth token. I'll say your auth token. And again, what we want is this auth token. I'm going to copy that and paste that here. Awesome. And I'm going to click update. So I'm going to go again and choose edit, and I'm going to go to authorization. And now that we have it, Postman allows you to use those variables wherever you want to, and you can replace them by using a curly brace. Sometimes those are called mustaches if you look at that sideways. So we'll do Twilio account SID, right? So it's double mustaches, right? So mustache, and then it does that. So mustache, oops. And for the password, we'll do show password just so we can see that we're doing it right. We'll do mustache, Twilio, auth token. That's how this works. So there we go. So that is going to set the authorization for all of the collections to these variables that are local to our machine. Make sense? There we go. So we'll click OK, update. And now let's go ahead. I'm going to close this window here. It's this little thing, and I'm going to click send. Okay, so we've got the authorization headers in place. We'll click send. There we go. Beautiful. Much nicer formatted. See, here we got our messages. We got an array of messages that came back, and we have ahoy from terminal. And we should have another one. There's nice URIs that we could go look at other things like feedback that came from it or the media that's attached to it. And here you'll see the original one we did, that was ahoy. And you'll see that the cost of it was 0.007 of a cent. So awesome. Now that we've got all of our foundation set up, we've got our collection and we've got our variables set up, let's go ahead and let's make it so that we can send a post from this right after a quick break. So we've got our message logs all set up in Postman. So now let's use it to create a post request. Now, since we want to use that same authorization that we used in the message log, we should put it in the collection and folder. So let's go back over here. Again, if this is closed, you click this little icon down here to pop this out. So we're going to add a new request inside of the Twilio SMS here, and we're going to make an add request. And the request name is going to be create a message. So we'll say creates a text message. And then let's see if I have the Twilio docs up still. I don't. So we'll have, again, we'll search Twilio message. There it is, filling it out for me. Message resource reference. And over here on the left nav, we can see that there's different bits. We want this create a message resource. This is definitely what we want. See, there's the URL. So we will copy that and bring that back over to our Postman. And we'll say Twilio documentation. Awesome. And it's in the SMS folder because that's when I started it from. Let's bring this all the way up and we'll say save to SMS. That's the folder. Awesome. So we have this create a message. So let's see. In order to create a message, remember we're going to do a post. And it's that same URL that we were using from the get message log. So see how there's two tabs here? So I'm going to switch back over to my get. And oh, look at this. We see here that the account SID is in there, and we don't necessarily want to put our account SID there for each one. We want anybody who uses this to be able to use it. So let's change that to use Twilio account SID. So that will use the variable that we've created, right? So it's going to replace that automatically here, and then you can see what it is by mousing over it. And let's click send, make sure that we got it. Cool. Now this is a usable URL for anybody if we were ever to share this. I'll show you how to do that here in a second. So we'll paste this here. And when we're creating a message, we're going to need to send some additional information, right? So if we click over here and we click on this body tab, so we're going to send some values. And in the curl command, we sent that using form URL encoded. So let's do that. And what were those values though? Oh, you know what? I should pop over to the documentation. I am sure glad that I made that link so I can click here. Open that up. Cool. So we definitely need a 2. That's right. We need a 2 from. It says you may also need to pass a body or a media URL with the message's content. Media URL. Does that mean I can send pictures? Cool. We should do that, shouldn't we? Cool. So there's 2 and there's from body and media URL. Okay, cool. And I'm going to set this to the curl language. You see these different programming languages here. We're going to set this to curl so it's in the right format here. So there's media URL, and the 2 and the from have capital Fs there. So that's the format that we want. So we'll say 2. And that's my number that we want to send this to. So that's 1-503-461-5537. So let's add a body. So we'll do body. Again, need to make sure that it's checked. So body, and we'll say sent from Postman. And you can actually send, in these messages, you can send emojis, which who wants a text message without emojis? My frequent used ones, muscle, taco, frowny, love, rocket. Sent from Postman. Awesome. And why don't we send a media URL? We saw that there in the notes. So we'll say media URL, and the URL, you can send any sort of GIF or GIF or whatever you can send here, whatever you want. I'm going to copy and paste one of my faves that we can send. Feel free to use your own image. I've left some fun suggestions in the notes if you want to copy. Giphy is a great site to find those. So let's see, we got 2 body media. Oh, we need from. We need from. So that's our Twilio number. So I'm going to click in here and I'm going to say from. Actually, this is something where this is my personal number. So why don't we add a variable for that? So I'm going to flip back over here to the Twilio variable. So we'll come back to Twilio edit, come in here to variables, and we'll add a new one for, let's call it Twilio number. And I'll say your Twilio number and our Twilio number. Let's look at that. It's in the console. So Twilio/console, here's our trial number. That's what we want. Copy and paste that. And we'll paste that here. There we go. Say update. And so the from value, we can use Twilio number. Awesome. All right, this is feeling good to me. Here goes nothing. We're going to click send. And boom, 201 created. Awesome. And I just got my text message. And there's my GIF. Pretty cool, right? So creating an MMS or multi-messaging service message is a lot more difficult than this if you were to attempt to do that by scratch, but the abstraction's in place, right? So it was pretty much seamless for us. Now, you'll notice here that the message says, maybe you won't notice, the status here says queued. But if we go and we look at our message log and we run this thing again, we can see that there's our sent from Postman, there's our emoji, and here's some more information. And if we scroll down a little bit more, we'll see these sub-resource URIs, and now we can see this media that was sent along. So let's go ahead and I'm going to just click this link and watch what it does. It's going to make a new GET request. Now, there's a bit of a problem because this GET request is outside of our collection. So typically when I need to do something like this, there's a little hack that you can do so you can get the authentication information. So let's just click save, and I just call it, you can just call it that if you want to. And I'm just going to call it temp because we'll delete it when we're done here. So we'll just call it temp. Save that to SMS. And when we run this, we'll see that we got back the list of medias. And because you can send multiple, right? You can send multiple pictures in a fifth. And we'll see here that there is an official one. And see how it is accounts and then messages and then media. They're sub-resources. So I'm going to go ahead and I'm going to click on that. And if we wanted to, we could run this request and it would show information about the media. But if you actually remove this .json, it will show the form of whatever the media was. So we'll make this request and watch what happens. See, we got back my GIF that I sent. And with a request of this size, we probably don't want to be making that request again if we don't need to. So this sounds like the job for client-side caching. Let's see if our API supports caching tricks. So what I'm going to do is I'm going to inspect the headers that are on this response. Nice, so it has this last modified header here, which is a good sign that it does support caching. So let's go ahead, let's copy this value. So I'm going to copy this date here into the clipboard. And if I go up to where my request was made, if I come into headers here, I can add a new header. And I'm going to say if, and you'll see that Postman's doing a really good job of showing me what's available. So if it's been modified since that time, because this is basically what your client would do, right? It says if this thing has been modified since this time, then show me anyone, otherwise don't. So that's what this does. So I'm going to go ahead and I'm going to go ahead and click send. And you'll see that my API returned this time not modified. So our API supports caching.
Which, ding, 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 means we covered another part of RESTful API constraints. Using standard HTTP caching mechanisms like last modified and e-tags, a RESTful API should support caching. It's up to you to maintain the cache on your client and decorate your request, but this can come in really handy to avoid making unneeded requests.
Awesome. So let's make sure that we've got these saved. You see these little orange dots here means that they haven't been saved. So I'm going to click on it and click Command S or Control S. And I don't really care about the temp, and I don't really care about this one. That was just kind of exploring. So let's take a look here. We have this temp. We can choose and say delete, and we'll delete it from temp. And now we just have our message and our create message. One more quick thing before we wrap up. I wanted to show you can actually generate code from this. So if you click in here, you can see here's an example of generating a code snippet. It's going to actually run through the code and set up everything that you need to run this code. Now there are things called helper libraries that will do this, and Twilio has one, and we'll look at that here in a second, but this is pretty slick, right? Really, really powerful. And you just copy it to the clipboard and boom. Pretty powerful, huh?
Awesome job diving into Postman. It's a super powerful tool and it keeps getting better every day. There are so many features that we didn't even cover. We barely scratched the surface. Check the notes for where to learn more. We saw how to organize our requests together into collections, as well as share common and secure values by using variables. We learned how to add different values to your request, both in form values and headers, and we also saw how to navigate through various sub-resources by clicking URIs. We even saw how to create actual runnable code from your request. While we were in the Twilio documentation, you might have noticed the code examples on the screen. On that page, it's possible to tab between various language implementations and solutions. Many products offer what is known as an SDK, or Software Development Kit, or helper library, that allows you to interact with their product in your native language. As you can see, it abstracts away the REST API completely. Let's take a look at the Twilio helper library next. Before that though, just a quick reminder to make sure that you check out the notes on this video. There's a link to a repository of built-out collections that are ready for you to use. There are lots of great APIs to practice with. Postman and curl are both great tools for accessing and exploring APIs. However, when it comes time, most likely you're gonna need to write some code. As we saw in Postman, you can actually generate code. All programming languages come with some sort of way of making requests. And as you know, HTTP requests are all we really need to interact with REST APIs. Now, writing that sort of code is totally fine, but you'll find out that you end up writing a lot of what is known as boilerplate code. Now, by boilerplate, I mean code that is repetitive and almost always the same, just with a few tweaks. Many products and services have created a solution to help you avoid this problem. They're often called helper libraries, or SDKs, software development kits. They'll be specific to your programming language. These libraries help to make your code more concise and legible. They usually also provide additional documentation for your editor, which I find super handy. Let's go check out some of these helper libraries.
Let's explore both a JavaScript and Python helper library. In order to do that, I'd like to make sure that you have both Node and Python installed on your computer. I've put installation instructions in the notes. Let's get started with Node. So I'm going to open up the terminal on my Mac, and I'm going to make a directory called Scratch. And I'm going to change into that directory. And in here, I'm going to make a directory called JavaScript. And I'm going to cd into that directory. And I'm going to open my editor in this directory here. So I'll say code dot. I'm using Visual Studio Code. So we're going to open up Visual Studio Code. And over here in our directory, I'm going to add a new file. And I'm going to just call it explore.js. All right. And what I'm going to do is I'm going to install the library. And in Node land, that is called npm. So I'll open up a little terminal here in Visual Studio Code. And I'm going to run npm install Twilio. And that's going to go out and it's going to get the library so that I can use it. And I can use it like so now. Now I can say const Twilio equals require Twilio. And then we're going to initialize it. So we'll say const client equals new Twilio. And as you can see, it takes an account SID and an auth token. And I have those available for us here. So here's my account SID. I'm going to copy that. And we will make the auth token after that. Here. All right. So we'll put that. Awesome. Now, can you think of anything wrong with doing that, with putting my account SID and auth token there? Well, right now, this is just sitting on my machine, but if I were to upload or share this with anyone, my credentials are sitting right there waiting for anyone to steal. Typical solution here is to use environment variables, and we'll do that when we build our application. But this is just a friendly reminder. Be careful with the keys. What we're going to go over here might very well be overwhelming, but it will make sense someday if you stick with it. I promise. I've added notes, but really, don't let this stress you out. The reason why I'm talking about this behavior is because the Twilio JavaScript client works like most JavaScript libraries. It's asynchronous, and it relies on a concept called promises. So the way that promises work is that you set up handlers for when your method call actually completes. So to get our message log, we use this method. There's a method called, so we do client.messages.list. And what that method returns is an object that is called a promise. It's a promise of a future value. The future value in this case will be our messages. So promises have an important method on them, and it's called then. So I'm going to go ahead and chain on that message. So I'll say .then. And this method should be given a function that accepts a value. So I'm going to pass it a function. Now, in modern JavaScript, you can use what are known as fat arrow functions. So what I'll do is I'll put the name of the value, and the value here is messages, right? Because this is what I'm expecting to be returned. And then I'm going to put a fat arrow, which is an equal sign greater than. And then I'm going to put the function body. So let's just log out the most recent message. Okay, so we'll do console.log. And I'm going to use backticks so that we can get string interpolation. And I want it to be the first one in the array. So we're going to say the most recent message is $ curly brace messages 0, because it's an array, dot body. And that is a long line, and this happens quite a bit. So typically what we do is when we do this chain is we press enter here and we put that on its own line. Still pretty long, still off the screen. And if I ask this to format with prettier, let's see what it does. There we go. See how it's done a pretty good job of getting things close. So, and then again, just to show you that this is running asynchronously, I'm going to below making this call, right? So this looks like it's after that call's made. Well, it is after that call's made. It's just that call's going to be asynchronous. I'm going to say gathering your message log. So let's go over it real quick. What's going on here is that we are getting a hold of the client, and we're setting up a new client so that all requests made against this client are authenticated, right? So that's our account SID and our auth token. And then we're going to use the client. We're going to use the messages route there. We're going to do a list, and that list is an asynchronous method. Now, while this has been abstracted away, we know what this is doing. It's making that same GET request that we did in Postman and in curl. And we know that it will return a JSON response. But because this is asynchronous, immediately it's going to move on to the next line. It's going to say gathering your message log. And when that call to list returns, it's going to run this function. And it's going to pass in the return value of that response to here. Now you should note the return value here is an actual object. It's not a JSON response. That sneaky little helper library of ours has also abstracted that away for us. It took that HTTP response, which has a body of JSON, and it automatically turned it into an object for us. And you can see that here it's an array of objects, right? So it's at the 0th. Okay, so let's run it. So I'll do clear down here, and we're going to say node explore.js. So we should see gathering your message log and then the most recent message. Fingers crossed. Here we go. Awesome. Yes. Okay. Now, one thing that we should make sure to do here is to capture any errors that might have happened asynchronously. Right now, if an error happens, it'll be swallowed. Well, actually, let me demonstrate what that means. This bites me all the time, and I don't want it to bite you. Let's say that you accidentally trimmed the last character off here, the 7 of mine. Let's take the last one off here. So I'm just going to do that. So it's an invalid SID, and I'm going to save and I'm going to run it. And it's going to say gathering your message log, and then it's just going to end out. No error, no nothing. But the results never came back. So what we need to do is we need to catch any errors that might occur. Every promise has a method named catch. And what might not be clear here is that this then here that's returning, this is actually also a promise. So I can just chain on here. So I can say dot catch. And I'm going to catch an error. And again, fat arrow function, and we'll just log that error. So we'll say console.error err. Okay. So now we've got, it's going to chain, and if anything happens, it's going to send the error. So let's try that again. Let's see what happens now with our catch in place. Awesome. It tells us that it wasn't found because that's wrong, right? Great. This is probably a good time to remind you, if that was way too much information, that you can and you probably should scrub the video back and watch me do it again. I guarantee that you'll catch some stuff you missed the first time. And at the very least, you'll spot a dad joke that I made at the very beginning of this video. I had said, this will make sense eventually. I promise. I'm sorry, I'm kind of obligated to make that joke. And if that doesn't make sense yet, that's also okay. Check the teacher's notes for more information on promises. Let's change gears and take a look at the Python version of the helper library right after a quick break. I know I need one. See you soon. We just took a look at the Twilio JavaScript helper library, and now let's take the Python helper library for a spin. Now, if you don't have Python installed, pause me and check the teacher's notes for instructions. In my terminal, from my Scratch directory, I'm going to create a new Python directory. So I'll say make dir Python, change into that. And while we're here, let's just check and make sure that we have the right version of Python. So I'm running Python 3.7.3. As long as this first 3 here is a 3 and not a 2, we're good to go. Python uses the concept of virtual environments. Now, these allow you to install packages local to this application, so let's do that just to be safe. So that's done with the -m and then vim for virtual environment. And I usually just call that .vim. So that will create a directory called .vim that is right there. And here we go. And what happens is, now I'm on a Mac, so this might look a little bit different on Windows. If you do .vim, there is a directory called bin activate, and I'm going to source that file. I think that's a .bat file on Windows. Check the notes. And you'll see now that I am activated. So I've got this .vim here. I'm going to go ahead and open up my editor. So I'll do code dot. And here we are. There you see my .vim directory. And I'm going to add an explore.py. All right, and I want to install the Twilio helper library, so I'll do a control tab. And you'll see that my editor actually went ahead and ran that argument for me. So I'm activated here, which is good because I want to install a package here using pip, which stands for the cute recursive acronym of pip installs packages. So that's pip install, and again, Twilio. Cool. So it's installed and we can start using it. So I'm going to go up here and we'll say from twilio.rest import client. And we'll make a new client. And again, it can be instantiated using, so here it's given us this nice information that's available about the API. So we'll put in here, again, this is our account SID. And boy, it really wants to show us that account SID and auth token. So let's get that. So again, account SID and auth token. And let's get these on some new lines by themselves. Again, really bad practice to leave your keys out like this. We'll fix that in a bit. Now, let's print out the call log real quick, just to show off the similarities and differences between the libraries. So the Python version is synchronous, right? So we can just iterate through those lists of messages. So we can say for message in client.messages.list. And we will say print the message.body. All right, let's see what that looks like. So we will do Python explore.py. And I didn't save it, so that's an important part. Python.explore.py. And there we go. Sent from Postman, ahoy from terminal. So awesome. So let's go ahead and we'll comment that out for now because we're going to do something else. So those are commented out. And let's write some code to send a new one. So we'll say message equals client.messages.create. And in here, we are going to pass our variables. So we're going to send this to me. or to you in this case, 503-461-5537. It's my number. And the from, now you'll notice that from is a keyword in Python, right? So see, it's like from Twilio rest. So what's nice is the Python library has made it from underscore here. It helps for the reserved words. So my number, my Twilio number, what was that? Here it is. It's my Twilio number. Awesome. And let's do a body, and we'll say body, hello from Python. And let's go ahead, let's print things out. So Python has a nice little thing called f strings, which will allow you to print variables that are in scope. So we'll say if created a new message, and let's just show the message SID to make sure that we got it. And we can just do msg.sid. Okay, so it starts with an F, and it uses the mustaches around this for message.sid. Very similar to those string literals in JavaScript. Let's go ahead and create this one. So we will run Python explore, and this should send a message. And it did. And again, I want you to see we are abstracting away the fact that we're posting to the messages sub resource under my account. It's just magically happening because we've logged this client in. Pretty cool, right? The other thing that this abstraction gives us is we have instance variables that represent our resources. Now, it might not have been clear up here when I looped over these objects, but they're actual objects. It's not just data. They actually have methods, and I can call the delete method on this message, and it will get deleted. In fact, that's not a bad idea. We've been doing a lot of test exploratory messages. Let's just delete them, okay? So what I'm going to do is I'm going to come up here, and I am going to uncomment this code. And I'm going to comment out our creation message code. And let's make this an F string here. So we'll say deleting message body. Here we are. We're going to say message.delete. Cool. Now, before we run this, I want you to make sure that you understand that we're going to delete all the messages in your account. If you've been using a live account and have things that you want to save, I highly recommend not running this. Okay. You've been warned. So here we go. I'm going to update this. There we go. So we've just deleted all of our messages. So if we come and try to run it again, you'll see there's no messages to loop over. We've done it. Clean slate. It's like the nothing never was. Pretty cool, right? That helper library was able to abstract away the HTTP delete call, and it used the information that it had available in its object to make the call itself.
Awesome. You see how the helper libraries are similar, yet match the development workflow and style of each language? This is one of the key benefits of helper libraries in general. They abstract away the HTTP client connection of the REST API boilerplate. They also behave as you expect them to behave. It feels natural. The way that we were able to delete from the resource itself helps to unlock another REST API constraint scavenger hunt item, and that is uniform design. Now this constraint has 4 subsections, one of which is what we just discussed, resource manipulation through representations. Because there was enough information included, it was clear how to modify and delete this resource. Another subsection in here is resource identification in requests. Those are the URIs that are included. Because the URIs are included, we know that we can get and manipulate specific resources. Uniform use of the HTTP verbs is pretty powerful. We just wrote some scripts that make use of helper libraries. These libraries are super handy for automation-based tasks or batch scripting, making a whole bunch of calls at once. While we're talking about this, we should cover another common tool for talking to external APIs, and that is the CLI, or Command Line Interface. There's that I again. Command line interfaces can be used to make API calls from an executable on your machine. More and more, these are showing up for all sorts of tools that require authentication and do a bunch of different services. This concept is popular amongst cloud providers where setting something up needs to be done quickly from the command line. Check the notes for more. Another common place where you'll use helper libraries is from within applications that you're building. Let's get to the final unit of this course and implement an external API into existing web applications. You've got this. By now, I hope you're starting to see that external APIs allow you to add pretty incredible features to your applications. Want to send a Slack message when someone fills out feedback on your website? There's an API for that. Want to change the color of your lights in your house when your favorite sports ball team scores? There's an API for your team and for your lights, if you want it. Want to send yourself a text message 10 minutes before your bus shows up? APIs are there too. Heck, do you want to make a Furby dance? It's got an API. They're everywhere and give you lots of power. We've seen how to use them from the command line, and we've seen them used in scripts. But now, let's take a look at embedding them in a web application. I've gone ahead and built the starts of a web application for us to play with. Now, one thing I know I don't do enough of is to compliment my friends and family and even coworkers. Sometimes the web can be so negative. So I was thinking, what if we made a web app that did the opposite of that? Introducing Complimenter. So the way it works is you fill out a web form for who you're complimenting along with their mobile number. You say why they're great, and they get a text message telling them how great they are and an encouragement to do the same. And of course they will. And when they come and see the messages that have been sent by everyone else, they'll be pleasantly surprised. Pretty sure we have a viral success here. So if there happen to be any venture capitalists watching, that's my phone number there. Now, if building and deploying a website feels a little too much for your current skill set, have no fear. I've created a couple of repositories of code that we'll be using. We're going to use a fun, approachable tool called Glitch to host our websites. The website is basically functioning, minus our API that we're going to add. If you haven't used Glitch before, it's a collaborative community built around learning. You take existing projects and you remix them. It has an online editor. So, I want you to head over to glitch.com and create a user for yourself if you haven't done so already. After you're all set, let's get to adding our API to the application.
First, let's take a look at the Python-based web application. We're going to be using a web framework called Flask. Flask provides an API that lets you extend the framework to create your application. This example application is going to be doing server-side rendering. This means that the pages will only be created on the server side. Any change or navigation will require a full page reload. In the notes, I've included a link to the repository where I've got our starter code. So go ahead and copy that. Now, I'm going to open up glitch.com. And I'm going to choose New Project. And from here, I'm going to choose Clone from Git Repo. In here, I'm going to paste what I pulled out, and I'm going to do, this is the one for Flask, so I make sure that's the one that says Flask. I'm going to click OK. I've been having a couple of problems with this. Sometimes this will just sit here and say Loading Project. If it does, just try that same thing a couple of times. Let's see what happens here. Sort of times out a little bit. I guess it's safe to say that Glitch is glitching. No, that's not fair. There must be some sort of bug that's happening right now. I'm experiencing it. I want to record this just in case you run into it too. Just do it a couple times if that happens. I do want to point out that it is pretty amazing what Glitch is doing. It's pulling us over. It's setting up a whole new environment for us and a web server that can run. And I actually have one that's up and running. I did the same thing where I made a new project. And you'll notice I'm not even signed in. So that's fine. They let you not even sign in and create these things. Okay, cool. So here we are. Down here under Tools, there's a thing called Logs that you can open up, and it will show you what happened. This is what happened, though it set up our web server here. And you'll see that the server is actually running. And if you come up here, you can go and click on Show. And the sunglasses here, your future's so bright, you've got to wear shades. So you can click View in a new window, and you'll see that the application is up and running, which is awesome, right? And this URL here, this is all yours. You can use it to do whatever. So the application itself, it's pretty simple. It's just a page with a form. And this section in here provides messages when they eventually come in. But as of right now, we don't have any because we just erased all those, right? But as of right now, we don't have any way to send text messages. We don't yet have the Twilio helper library installed in this application. So let's go back over here. So these are the files that are available over here. So you can see here's app.py. And there's some settings that you can do up here. You can come in here. You can actually change the name of this to be whatever you want to be. So I'm going to call this Complimenter. And we'll say compliment your friends. Cool. And this is another nice thing you can do is you can change the theme. I'll put it on dark theme. I don't know when you're watching this, but this should be okay both in light and dark. So there you go. You can also delete this if it's not something that you want, if you ended up creating something. So cool. Awesome. So this app.py, this is our program. Flask works by creating an object called app. So you do this Flask name and it creates this thing called app. And then what you can do is you can put different routes in here. So for instance, when we go to /, which is the index page, right? It's going to do a get and it's going to render this template of index.html. And that is in here under static templates index.html. Then you'll see here, this is how the page is laid out. There's some dynamic data here. We're using some if, and it's going to loop through messages should they exist. And we'll look at how that works here. And then we'll see there's a form that's doing a post to add complement. Let's look back at app.py and see how these two line up. So it's going to come in and it's going to call get sent messages, and get sent messages is not implemented. I left this here as a to-do, so we can fix that as it goes. So, and then it basically pushes those messages, and since it's an empty list, it will just go. So in here, we can see that there's an add complement, and it's happening when a post happens. So it's going to run this function when a post happens. And again, that post was happening from the form. And we'll see what's happening is it's just pulling off these variables. We've got sender, receiver, complement. It's pulling off 2. And if we take a look at back at here, if we look at our form, we'll see that there's the 2, and you'll see the name is 2. So that's what's getting pushed across. And there's sender and receiver and complement. So they're pulling those through. It's kind of building a message for you. So sender says, and it's using that F string, right? Sender says receiver is complement, see more at request.url, and we'll send that message to body. So it's going to call send message. And right now send message is needed to be filled out. So this to do here is actually a pretty good place to start, right? We need to send the text message. Otherwise there's no messages to show. And we know how to send text messages using a RESTful API. No sweat. We can do that. So I could use the Python HTTP client and write my own messages. That seems like a lot of extra work, right? So I'm going to use the Twilio helper library. So in Glitch, you can access the terminal from your application by down here. If you go into this tools and you come up here to logs, and then come over here to console. And see that I've now got a terminal running, which is pretty powerful, right? So I'm going to type source dot, and then it's in .vim, bin activate. Remember we had done that before, so we're going to activate script. Now we're activated. And you'll notice that I've got this here, this vim. So now I will go ahead and I'll do a pip install Twilio. So we'll get down that Twilio helper library so that we can use it in this application. Awesome. So it's all installed. So we should be able to use that. I'll go ahead and close this. And it went and it downloaded everything that we needed, right? So it got it. But if someone was to come along later and use it, the way that it knows what to install is there's this requirements.txt file. And you'll notice the Twilio stuff isn't in there. This has just got the stuff for Flask. Jinja's part of Flask, and Verxwig is also part of Flask. It's got just the stuff that was needed. So they won't have the Twilio library. So we want to get the Twilio library in here. So the way to do that is let's get back in here into the console. So first, again, we're going to activate source vim bin activate. Okay, so we're going to use pip freeze to show all of the packages that we have installed, and then we can store its output, and we can do that in this requirements.txt. I'm going to go ahead and do that. And when you make a change in the console, you have to do refresh to make sure that it shows up. So now if we look in here, we will see that we have Twilio is now available for whoever comes to use this later. Cool. Let's write some Python. Okay, so back in app.py, I'm going to come in here and I'm going to say from twilio.rest import client. So this line here, this load.env, will load environment variables from a secret glitch file that I have over here, this .env. I started it for you. Now, why don't you pause me and go get your keys and phone number and fill this file out? This is kind of like the environments that we saw in Postman. So go get those. Do you know where they're at? Go ahead, pause me, And when you're all ready, unpause me and I'll show you how I did it. Ready? Okay, so here's how I did it. I went to my Twilio console and I copied my account SID. And then I went to my auth token and I copied that and I pasted that there. And then of course my Twilio phone number is my trial phone number right here. And I'm going to paste that here and save that. Except I don't need that. Why? There we go. Cool. So let's flip back to app.py. And if we take a look here, there's a thing called Twilio phone number, and it's using this os.getinv for get environment Twilio phone number. So it's pulling that from here. So in our application, automatically this will be set up. Nobody else can see this. This is your personal information, but here I've got that stored in a variable. Pretty cool, right? So let's go ahead and let's create one of those clients, right? So we'll say client equals client. And here's a little fun fact. If you don't pass any arguments to the client object on creation, it will look in your environment variables for those Twilio underscore values. So like the Twilio account SID. So environment variables are an excellent way to keep your keys hidden and not leave them sitting in the front seat. Check the notes for how to do that locally on your machine. So now we have an authenticated client that we can use to complete these to-dos. So the first one I think we should do is tackling that sending the message, right? That was down here. We're going to send this message. I'm going to come in here and I'm going to delete this keyword called pass. And I'm going to start with, actually, you know what? You got this. Go ahead and write the code to send a message. Now, don't worry if you didn't memorize the syntax. I've put links in the notes to the Twilio docs. Ready? Pause me and write the code to send a message using the to, the body, which is coming here, right? So we got the to and the body coming in. And all you need to do is set the from, and you can set that from your Twilio number here. If you do it right, and fill out the form, you should get a text to your phone number. You got to text your number. So a couple of gotchas. In Python, spacing matters. So make sure that you're indented under the function. See how this is indented here? Make sure you're there. And remember that from, F-R-O-M, from is a keyword in Python. So it's from underscore, right? You ready? Go ahead, write some code to send a message. Pause me, and then I'll show you how I did it. Ready? You got this. Okay. How'd you do? So here's how I did it. So I used the client and then I used messages.create and I passed in to, and that's what's coming in from the function there. And the body is also what's coming in from the function there. And then I had to use from underscore, and I'm going to say the Twilio phone number. Awesome. And I'm going to click the show in a new window. Cool. So we're going to text my number here. So that's +1 503 461 5537. And we're going to compliment me. Person to compliment is Craig. We're going to say Craig. Craig is completing to-dos. And we're going to send the compliment. And I should get a text that says that my message was sent successfully. And awesome, I got it. And now I'm going to remove that to-do. Doesn't that feel good? I love removing to-dos. There's nothing better than that. So what do you say we get the next one? Let's do it. We can do this. Make this return a collection of messages that were sent from the number. Should we do it? Let's do it. So get sent messages is used in this index function, right? So that's what's pulling out the messages. So let's take a look again real quick at that template. Yeah, so it's saying if messages, if there are any messages, for message in message, write out the message body. So that's going to just loop through those messages. So we're going to pass through the message object and a list of those message objects. So in this get sent messages, we see that it's an empty array. So that's why it's never showing up. So we want to replace this with a call to get the client call log, right? Do you remember how we did that? Okay. You have a link to the doc. So go ahead, give me a pause and see if you can't get it. If you get it and refresh the page, you should see the message and recent messages. Ready? Pause me. I'll show you how I did it after you unpause. You got this. Okay, this is how I did it. So I used client.messages.list. And remember, we could be using an account that has multiple numbers. So we really only want to get the messages that were sent from our Twilio number. So again, that's from with an underscore. And we'll do Twilio phone number. So that's a way of querying that, right? So we're saying we only want messages that were sent to the Twilio phone number. And if I come over here and refresh, there it is. Craig says Craig is completing to-dos. See more compliments at http://complimenter.glitchme. So yours will be whatever yours is there. Pretty cool, right?
Great job getting that application up and running. Because it's actually running, you could totally share that out now by sending a text message to someone you trust. Wait, well, actually, maybe you can't. I seem to remember something about our accounts being limited to verified numbers only while in trial mode. Now, API limits are probably something that we should look into really quick, since they're pretty common with every API that you might encounter. Let's take a quick detour and explore some limits, and then we'll get right back to implementing this app in a full-stack JavaScript app. APIs are designed to have limits. And as you can imagine, if you were the maintainer of a web-based API, you wouldn't want someone making millions of requests in a short period of time. Now, chances are your API server couldn't support the load. The typical solution to this is to throttle or limit the number of requests that you can make per second. Typically, these limits are introduced when you get your API keys. If you'll recall, on the Twilio console, where we got that trial number, we were informed that not only will messages we send during the trial have that trial text that we've been seeing, it also said that we could only send to verified numbers. What do you say we see what happens if we try?
Now, I don't know about you, but I find that having people that support you in your life to be super important. Now, for me, hands down, that person's my mom. Like, no matter what I'm doing, she's just there in the sidelines cheering me on. Whenever I launch something new, you can pretty much guarantee that she's helped me test it out. So I'd like you to do this. I'd like you to think of someone like that in your life. And I'd like you to send them a compliment using Complimenter. So I'm going to add my mom here. So I'm going to add her number, and that is this one, 602-609. 5813. So I used to just press a mom in the phone, right? So I'm going to say, my name is Craig, and I'm complimenting mom. And mom is infinitely supportive, as you'll soon see, I'm sure. So obviously, you should put in your friend or family or colleague here. Here we go. All right, so I'm going to click send compliment, and ooh, new internal server error. Yuck. Let's go and look at our logs and see what happened. So we've got a pretty big stack trace here of what happened on add compliment. If we come down here, it says the number is unverified. Trial accounts cannot send messages to unverified numbers. Oh, right. Verify. Oh, we can verify them at twilio.com. Verified. Let's go ahead and do that. Can I can do that. That's cool. Go to. Awesome. So now I need to get my mom's number in here. I need to get her to be verified so that she can see it. So you can actually do this pretty easily. And what this will allow me to do is to be able to have my trial account be able to text her, which is all we need, right? So what I'm going to do is I'm going to click add, and it will call you with a verification number, or I'm going to make it text you instead. So what I'm going to do is I'm going to put in my mom's number here. Put in 602-609-5813. So what I'll do now, before I click the text me, is I'll say, hey, mom, I'm texting her this. It's me again. Hey, I'm going to verify your number. You're going to get a text from Twilio. Can you send it back to me? And she wrote back, sure thing, sweetie. Aw. Okay, so now that I know she's ready, I'll now send that validation message. And so I'll click text me, and I will wait for my mom to tell me what that was. And then she should be able to send me the code. Okay, so she texted me, and that number is 946541, and when I click submit, awesome. So now my mom is verified. Here she is. She's in this verified numbers. Now I can text her. Now let's go try that again. Let's get back to this internal server error, and I'm going to refresh, reload that, and it's going to say, hey, you're going to submit the form again. That's totally fine. That's what I want it to do. It's actually what I want it to do. And we say continue, and boom. We did it. My mom should get a message. And she did. She just sent me an emoji heart. I hope you're now able to show off your app to your supportive person. It's really nice to have that support as you're learning and building things. If you don't have someone like this, My mom's pretty supportive. If you want to just text her, I bet she'll shoot you back some words of encouragement.
Now, of course, this app isn't going to go viral in this trial mode, but this is a great prototype of the concept. Most of the time, APIs will give you a chance to get your prototype together before they start charging you. But being aware of the limits will help you plan your efforts. Remember to carefully read the limits and error messages. Most APIs will guide you into how to deal with the limitations. Now, let's get started with a JavaScript-based implementation of Complimenter. Now we're going to implement that same Complimenter application, this time using JavaScript. I've got a full-stack JavaScript application mostly built and ready for us to tweak. By full-stack JavaScript, I mean the server is written in JavaScript, and there's some front-end code that's also written in JavaScript. On the server side, the application uses Node.js and the web framework Express. On the front end, I've used the client-side framework Vue. The Python version that we saw earlier was all server-side. There are some things to consider when implementing a client-side application when using an API. So let's explore those while we get this JavaScript prototype up and running.
In the notes, I've supplied a link to the repo that you can use to create a new glitch project. Go ahead and copy and paste that. I'm going to click clone from Git repo, and then I'm going to paste the repo. All right, so we're going to do the Node version. So this is Node. And again, if glitch takes a while to spin up, that's okay. It might eventually show up, or it might glitch out. And if it does glitch out like this, like sometimes it might just say the assets folder, just go ahead and do it again, and it will eventually work for you. Awesome. Here's mine working. The JavaScript version of this project is implemented as a very simple single-page application, or SPA. Now, what that means is that once the page is rendered, the client will be responsible for rendering parts of the page. We won't rely on a full page reload from the server to load new pages for us. Let's take a look at app.js, the server side of our application. So we're going to look at app.js. So let's see, this first .env here, this will load up our environment variables, which we'll take a look at here in a second. Then it's using Express, which is a web framework. And you'll note that it's exposing static files in a public directory. So this is a single page application, and it's rendered in public index.html. Let's take a look there, public index.html. So this here is the Vue dependency. If you haven't seen Vue before, no worries. This is a pretty straightforward way of using it. So what Vue does is it uses these v-, right? So it's these v- attributes, and those are Vue specific. So basically this is saying if the compliments.length is greater than 0, and we'll see how compliments is defined here in a bit. And as you can see, if it does exist, it's going to loop through each one of the compliments, and then it's going to write them out. So it's going to write them out using that double mustache syntax here. So it's going to write out the complement that's in this loop. Okay. So that compliments variable is initialized in our application. Let's scroll down to it. I've put the whole application in one single file here, so we don't need to worry about packaging or anything. So the way that you create a new Vue app is by saying new Vue, and you can see here there's this data attribute. And as you'll see, compliments is initialized as an empty array. You can add instance methods to your application by adding a methods object in the Vue constructor. So we have a method here called refresh compliments. Now you might not have seen this before, but if you've had a hard time keeping track of promise-based codes in the past, this feature here is the one that you've been awaiting for. You'll see here that the keyword async is before the name of the function. So it says async refresh compliments. Once a function is labeled as asynchronous, you can now cause functions that return promises to behave synchronously, meaning they don't move onto the following line until it completes. So this line here makes a fetch, right? So fetch returns a promise, but there's a keyword here of await right before it. And this code will wait for the fetch call to complete and then assign the future value of whatever this is into the response. And the same is true here. Response.json returns a promise, and this will wait until this is done. Now, one thing to note is that this async function makes it so that refresh compliments now returns a promise. And that is, its return value will have a then method that returns this value. Now, if that doesn't make sense just yet, just you await. It will. Just try and let it all sink in. was a dad joke double whammy. Sorry, I'm kind of obligated to make all these jokes. Really, though, most devs that I talk to find this async await more straightforward to use than promises for code that's actually synchronous in nature. All right, so what is this code doing? So it's making a GET request. Fetch's default method is a GET to a URL of /API/compliments. So that's in our server-side code. Let's flip back here to app.js. And you define routes with Express using this app.get. So whatever the HTTP method name is. So app.get/API compliments, that's what we saw. So when that happens, this function here will run and we'll pass in the request and the response. And here's our first to-do. So we want to get the message log. So first, before we do that, we better install the Twilio helper library using npm. So I'll click on Tools, and then I'll click on this Logs, and then I'll click on Console. Now I'm going to run npm install Twilio, and I'm going to do --save. What that will do is it will update a file called package.json after it installs. And this is much like we saw in the Python library where we did the freeze. This --save will update that file so that the Twilio dependency is there. We'll let this complete. Awesome. And so now when you make a change from this side, we always need to say refresh so that we can refresh the project and see the changes that we made. And so if we look in here under package.json, you can see that there is a dependency of Twilio. Great. So now that we have things installed, let's go ahead and update the env file. So that's this key. See this little key.env here? This is going to allow us to put our information in here. So I'm going to go ahead. I'm going to grab my account SID. You should do the same with yours and grab my auth token. And last but definitely not least, my phone number. All right, and now we can use that in our code. Let's go right above this port, right below this port here. We'll make a new Twilio client, and we'll require Twilio. Actually, that probably looks better up top a little bit more. Let's move that. Let's do that right. This is all out of alphabetical order, isn't it? Let's do this right here. There we go. And then we can instantiate one. That will look better down here. So let's say const client equals new Twilio client. And again, it's going to pull from the environment variables of the Twilio underscore. And just to show you how you do that here, so we'll say const the Twilio phone number. If you ever wanted to pull something else out of the environment, you use process.env the thing. So the thing was called Twilio. I think it's called phone number. Let's double check. Twilio phone number and env Twilio phone number. Yeah, cool. Awesome. So let's get that message log. So what I'm going to do is I'm going to replace this. So we're getting the compliment. So we're going to get sent messages. So this to do, get a list of messages sent from a specific number. Obviously our Twilio number there. So what I'm going to do is I'm going to replace this array with my code. And actually, you want to give this a spin? Well, one thing to note is that the function is marked async. So you can, and you probably should, use the keyword await, right? So this is an async function. So make sure you use the await keyword. Are you ready? Just make the call to the messages API to get a list of messages that were sent to a specific number, like the to-do says. Now, don't worry if you don't have it memorized. I put a link to the docs in the notes. Go ahead and pause me and give it a shot. When you unpause me, I'll show you how I did it. Ready? How'd you do? So what I did was client.messages.list. And in the JavaScript client helper library, you pass in an object with the parameters. So you say from, not a keyword here, and we'll say Twilio phone number. And like I said, we should make this be await because we're going to wait for that to happen. And boom, just like that to do. Well, why don't we change it? Why don't we take a look? Let's go. I'm going to change this to be complementer. That's not very nice. Complementer JS. Compliments. I'm going to close that. And let's go ahead and we'll do show. And we should see the messages come through. Oh, we shouldn't see the messages come through yet, right? Because we aren't passing anything through. We're passing down these compliments. All right, let's see. Let's see if we can get this next to do done then. Gather only the body of those messages for sending to the client. Okay. Oh, right, because we don't want to send down the whole message object to the client. So what we want to do, the API is called compliments, right? And we have an array of text messages. So more importantly though, if I were to send down this message, each one of those messages, it contains a bunch of information that I don't think we want to share with everybody. The message has the phone number of the people who sent the message. I should never send information that I want to keep safe down to the client. So really, we only want the body. So let's see. I have an array and I want a new array of just message bodies. Now, to me, this sounds like a great use of the array.map function. So sent messages is an array. So we'll say sent messages dot map, and the map function, map takes a function that will receive each value in the array. So that will be a message, and it takes a function. And if it's on one line, we can skip the return keyword and just put what we'd like to see. So this complements array, we want to see the array of message dot body. Right? So what this is saying is like for each of these messages in here, just return the message body and put it in compliments. Make sense? And then it's going to send down the JSON representation of that to our view client. Should we see if it works? All right, we'll save this. And now, oh, there we go. It's working already. So we'll see there's a new one from my mom. And it says, Mom says, Craig is so proud of you, sweetie. Oops. It's nice. It's sweet. She wrote back. And that's what I love about having someone use your applications. It looks like I still have some UI work to do to make it more clear about what's happening because my mom wrote, so proud of you, sweetie, in the compliment. And that doesn't make much sense, but I feel nice. And again, this is using the number. This was not sent from this app. You can see it was sent from the Python app, right? This is complementer.js, but this is using a different data source. And you know what? While we're here, why don't we look at how easy it is to see what the data was that was sent down from the server? So I'm going to right click and I'm going to choose inspect. I'm going to click on this network tab here. And I'm going to refresh the page and you'll see it make that request. So if I click on this compliments here, you can see here is the message. Here's that array that was sent down, right? You can imagine that if we sent down all of those messages, we'd have that data very easy to get. So again, this is the developer toolbars. If you say view, developer, developer tools, you'll be able to see this. I'm going to take a quick break and then I'm going to swing right back and finish up the remaining to do, creating a new complement. We just finished displaying a list of all the complements, and now it's time to deal with how they get added on the JavaScript side. So let's peep the front end code and see what happens. So that is in public index.html. So here's that form, right? So we have this, it's a form that goes to post, it goes to /add complement, and it's got these v-models. So here it's like v-model2, v-model sender. That's how Vue does data binding. So anything in that field will be bound to that variable. And if we come down to the button here, we'll see that the normal click, it will prevent, right? So that prevents it from being submitted, and it calls this send complement method, which is defined in the method stanza here, which is this send complement. Okay, so it goes ahead and it grabs the stuff from the form. So it pulls them all off. They also happen to be the same. It's in a thing called data. Then it uses fetch, and it uses it synchronously, right? So it's got an await. It's going to wait for fetch to go, and it passes that as JSON. And we're saying that it is JSON, and we're passing JSON up, and we're doing a post request. And let's go ahead and we'll take a look in app.js, and we'll see here that we're using this body parser. So any request that comes in will automatically get parsed. And the way that that looks is, so here's this post, right? So here's, we fixed this get. Oh, we got to get rid of these to-dos. I forgot to erase those. Those are to-done. All right, so it comes in here, and it's posted to API compliments, again, an async method. So it's going to pull off of the request body 2, right? So, and because the body parser was parsed, it's automatically inflated here. So body the 2, it's going to pull the 2 off of the field, and request.body sender, request.body receiver, complement, and it's using the backtick, so it's automatically filling those out. So here we are. Here's our to-do. Why don't we just synchronously create that message? You want to give this to-do a try? Go ahead, pause me. I put links in the notes. I'll await for you to unpause me and then show me how you did it. How'd it go? Here's how I did it. So we want it to be synchronous. So I'm going to go ahead and use await. And I don't really need anything from the created message, so I'm not going to assign a return value. And I'll use the fact that the parameters are the same. So I'm going to say client.messages.create. And in JavaScript, you can do this. If you have a variable named 2, it will just set 2:2 from embody. Right, so this is just basically, because there is a variable called 2, it knows to make a new one called 2 in this array here. All right, so let's give that a go. So I will go ahead and click show here. And I'm going to send another one to my mom. To mom. No, my name's not Mom. My name's Craig. And I'm going to compliment Mom. Her compliment is a really patient tester. Mom is a really patient tester. So here we go. Yep, there it is. So see, right away it came back, and you'll see that the form's cleared. So let's see how it did that. So back in the index.html, we have this. We posted it, and it got back the data, and it awaited for the result, and then it wrote out the result, and we saw this information come down. So we could actually, if we wanted to, we could do view, developer, developer tools. We should see in the console, here's the object that got sent back, so it was a success of false. Oh, we forgot to update that, didn't we? Let's look. I think we looked at that. Oh, we forgot to say, yeah. That was a successful journey there. Good job. Glad we caught that. Speaking of catching stuff, what happens if things go wrong? So much like before when we needed to capture the error using the catch method on promises, we need to do something similar in this async await land. So we need to use a standard try catch block. Now, if you haven't seen that before, it's pretty straightforward. What you do is you say try. And if any error at all is thrown, what will happen is it will call this catch block, and it's a good way to handle errors. So we're going to catch that error. So the error object has a status, and you can send that down to the client by saying response.status, and we can do error.status. We'll just pass that status straight through, and this is chainable, so we'll send JSON. We might as well share what happened. So we'll say success is false for real this time. And we'll also send, why don't we send the message? We'll send that error.message. There we go. And you know what? We can use prettier here too. So we're going to click this, format this file. Let's make this thing prettier. Ooh, nice. Okay. So we're going to try, and if there's a failure, we're going to send this back, and then otherwise we're going to go ahead and send down the success of true. So we got to break it somehow. how should we do that? Let's say instead of from, let's make this be 42, the meaning of life and everything. So that is obviously not a valid Twilio phone number. So let's go ahead and let's bring up complementer. And I'm just going to, oh, it did refresh. I was going to refresh it and it did it for me. So we'll send another message to my mom. My name is Craig, to my mom. And the complement is good at catching errors. Okay, and I'm going to click send compliment. Let's see what happens. Ooh, look. So here we got the error. It's a 400 that came back. And the from phone number 42 is not valid. CMS capable or inbound number or short code from your account. Here's a better version of it. Cool, right? And let's make sure we don't leave that in that state. So we'll undo that and save it. So I want my mom to give me another compliment. And we are good to go.
Awesome job. You've now used an external API in 2 completely different web frameworks and paradigms even. You should be sending a compliment to yourself. You're accomplishing great things. Way to stick with it. One other thing I'd like to take a quick moment to point out is that the server code that we wrote, you might have noticed it was prefixed with a /API. Server code that interfaced with a client. Now, here's my question to you. Do you think that the API code that we wrote together should be considered RESTful? Why don't we take a look at our weathered scavenger hunt card? So it's definitely a client-server architecture. Our client happens to be, in this case, a Vue application running in the browser, and our server is a Node.js server. But any client could connect and use this. It's definitely stateless, right? We aren't requiring any prior knowledge about the client. Well, at the moment, we aren't providing any caching information, though we could, right? We could fairly easily pay attention to those headers coming in and respond appropriately. It would require us writing some additional code and thinking through some edge cases, but we could do it. Let's put this in the maybe column. Yeah, for sure, right? In fact, it's a little layered already. Our API is calling another API, but our client doesn't need to know that. We could also add additional functionality and the contract wouldn't change. We haven't even talked about this one yet, and it's the only optional requirement. Now, basically, this means your API returns code that is runnable. Like maybe it returns an embeddable widget or some actual JavaScript code. This doesn't make sense in our application, and that's okay. I'm going to drop this one in the new. So we're looking good so far, but here comes the doozy. So remember, this one has 4 subsections. Ruh-roh. Currently, we're just representing all the complements as strings, and absolutely no way to identify them. So we fail this sub requirement, and therefore, this whole thing is a no. But let's keep going through the rest of these. Pun intended, sorry. We definitely do not allow any sort of manipulation of complements, so this is another fail. We haven't gone over this yet, but by using headers, we can tell that this is JSON. The message sent down has a type, and it is clear that it should be JSON decoded to be used. And last but certainly not least, HATIOAS, or HATEOAS, is an often forgotten about part of the RESTful constraint, and very hard to say. The idea here is that there are links provided to show off what more you could do with this and where you could find related resources. It provides URIs or links. We did see this in both the Spotify and Twilio ones. However, ours doesn't need to provide links to other resources. So we don't have a RESTful API, and that's okay. It works as is. It does look like we could get there pretty quickly if we wanted to. One thing I want you to gain from that exercise is that you now have the ability to identify whether or not an API is RESTful, and I hope that felt pretty good. We've now completed that scavenger hunt. We revealed all the constraints, and I hope that most of those are pretty clear. Please don't feel like you need to memorize those. You can find these same constraints littered all over the internet. As a prize for finishing the constraint scavenger hunt, I've dropped links to my favorite REST API constraint documentation for you to lean on. I've also included links to popular REST API frameworks that will help you design RESTful APIs. Make sure to check the notes. You did it. You just completed a whirlwind introduction to APIs, and I hope you see how much power they can add to your programming journey. By looking at interfaces in general, I hope you're more comfortable with the idea of not fully understanding exactly how something is working, but still leaning on that abstraction to build your tools and applications. We do this all the time with physical object interfaces, and APIs, or application programming interfaces, aren't all that different. I hope you enjoyed taking this course. I know I had a ton of fun making it. If you think someone you know might benefit from this course, share it with them. I'd love to hear your feelings, your thoughts, and your dreams, so I threw together a little something using a smattering of APIs to capture your feedback. If you've got the time, I'd love to have you answer a quick text-based survey. Text feedback to 1-503-461-5537. Actually, you know what? If you want to, you can also just call and leave me a message too. I used an API for that too. Please, please, please keep me posted on your journey. And really, I can't wait to see what you build. Thanks for hanging out.